In solving these log equations, they're asking us to round to 3 decimal places if necessary. So we are looking for a decimal answer to these. When solving a log equation, remember that you do want to isolate the logarithm first. So any numbers that are near it, we want to move to the other side. We're first going to use our addition-subtraction property by subtracting the 10 from both sides. Notice you can't add the 10 into the argument. That argument is sacred territory there. You don't get to do anything in there. So you got to just move everything away from it. So we have 2 log, remember that's base 10, even though you don't see it, 2x plus 3 equals 6. Get rid of the 2. So we're just going to divide it off. It makes it easier to divide it off rather than pull it up to the power position. You could do that, but it's going to get a little bit more complicated if you do pull it up to the power position. So we've got log base 10 of 2x plus 3 equals 3. Next, you want to get rid of the word log by rewriting it as an exponent. Remember, logs and exponents are opposites of each other, sort of. So we're going to take the base, make it big, to the power 3 equals 2x plus 3. And then start solving for x. So 10 cubed turns out to be 1,000 equals 2 times x plus 3. And again, we look for addition-subtraction property first before we do a division step. We have 997 equals 2 times x. Now divide both sides by 2. I'm going to squeeze that in there. So x equals the 997 divided by 2. If we were asked for an exact answer, there you go. For the decimal approximation, go ahead and do that division, and you'll come up with 498.5. Okay. For the next one, looks about the same as everything that we've done so far, but now we've got a subtraction symbol. So when I condense these, I have to remember to put the division bar in. Log base 2 of, and then the subtraction is the division bar. So the argument that's positive goes to the top. The argument that has the negative in front of the logarithm goes to the bottom. You can put little parentheses around them. Equals 3. Next, get rid of the word log by bringing your base down. 2 to the third equals 3x plus 4 over x minus 1. So 2 cubed, I can call that 8. This looks a little different than our other problems because before we were having to multiply stuff out and set it equal to 0 and then factor it. There was a whole process there. This one's a little bit easier. If you think about it this way, put the constant over 1 and then you can do a cross multiplication to clear the fraction. In other words, take 1 times 3x plus 4 equals, and then cross the other way, 8 times x minus 1. And then go ahead and distribute. So we have 8x minus 1. You need to collect your x's on one side, your numbers on the other. So I'm going to move my x's to the side with the bigger number. You can go either direction. I'm going to move my x's to the right. And then terms that don't have x in them, I'm going to move those to the left side of the equation. So the minus 1 doesn't have an x in it. I'm going to add 1 to both sides. Whoops. Well, let's back up here a minute. I was thinking there was something a little off. That should be an 8. Distribute there. So not add 1, but add 8 to both sides. There we go. So now I have 12 equals 5x. And then divide both sides by 5. Watch that distributive property. I mentioned it and then didn't do it myself. 8 times x, 8 times negative 1. All right, so I get x equals 12/5. And then convert that to a decimal, 2.4. Now I didn't also double check here. 2.4 times 3, that's going to be a positive something plus 4. That's cool. 2.4 minus 1, still positive, so that's going to work. Let's do a double check of that other one. Just because the decimal came up positive doesn't necessarily mean it's going to work. So I need to double check my 498.5. 498.5 times 2. Super big number, like 997, I believe, plus 3. That's going to be positive. So as long as the argument's positive, we're good to go on both of those answers. Let's come down here to this one. I see a plus sign, so that means I'm going to be multiplying those two arguments together. So x times x minus 3. That's base 10, remember? So log base 10 of, okay, now watch the distributive property here again. X times x, x times negative 3 equals 1. Get rid of the word log, bring down the base, 10 to the power 1 equals x squared minus 3x. 10 to the 1 is just 10. And then set it equal to 0 because it's a degree 2. So I'm going to have to either factor it or potentially use the quadratic formula if you know how to do that already. All right, so there's 3 terms, nothing in common. Write down my 2 sets of parentheses. I have x times x. Then to multiply to negative 10, but then add to negative 3. So I'm thinking it's a 5-2 combination. I want a negative on the 5 and a positive on the 2. All right, so if I put those numbers in, negative 5 plus 2, set each factor equal to 0. I get x equals negative 2 or x equals 5. And again, we're going to be a little suspicious of the negative answer. Plug it back in. Negative 2 minus 3, that's going to be a negative answer. Don't care what the other one says. If it fails once, you can't use it. Let's try 5. 5 minus 3, that's 2. And then 5 fits in there just fine. So we only have the one answer, x equals 5. For the last one on this page, I see a subtraction, so I know I've got to put a division bar in. Positive argument on top. Negative argument, or negative in front of the logarithm, goes to the bottom. That argument ended up down below because of the negative in front of the log, equals 0. ln is fancy log base e. This is a step you don't really have to write, because if you recognize what the base is of the natural log, you can go right to writing it as an exponent. So I've got my exponent, my base is e of my exponential to the 0 equals my juicy goodness inside the log, better known as the argument. So from here, e to the 0, any number, remember, to the 0 power is just 1. And then we're going to do our little cross multiplication trick. Throw the number 1 over 1. Cross multiply. So 1 times 3x plus 1 equals 1 times 2x plus 1. Distribute. Now this one won't be so bad because we're just distributing a 1. Get your x's on one side. And your constant on the other. So I'm going to have to subtract 1 from both sides. I get x equals 0. Plug your 0 back in. 3 times 0 plus 1, positive 1. 2 times 0 plus 1, another positive 1. So x equals 0 is a good answer.